what is gravitational field intensity, gravitational field strength or intensity denoted by E, and what is gravitational potential denoted by V for our shell. When we say shell, generally we have two things. We shall be talking about a shell and we shall also be talking about a solid sphere. Right now we are concerned about a shell. Shell is like a tennis ball which has a cavity inside, and when we say solid sphere, it is like a cricket ball which is filled inside. Right now we are considering a very thin shell whose internal as well as external radius that is almost equal to capital R only, and its mass is m. When we say shell or solid sphere, generally we are interested in finding the gravitational field intensity and gravitational potential at three places. One is when our point of concentration lies outside this sphere or shell, second is on the surface, and third is when this point lies within the shell or within the sphere. We are interested in finding gravitational potential and gravitational field strength, which is also known as gravitational field intensity. Now if we consider a thin shell of mass m and radius r, then this graph is for gravitational field strength or intensity and this graph is for gravitational potential. This way it is positive, this way it is negative, it is positive, it is negative. So when we go from 0 to r, that is 0 to r, that is within this shell, the gravitational field intensity is 0. It is 0 is over here, 0 is over here, so it is 0 till r, till radius, and suddenly it becomes gm upon r square over here, and then as the distance increases, this intensity it reduces, and at infinity this will almost become equal to 0. So it means the gravitational field intensity within a shell is 0. At the surface it is gm by r square. This is shown in the negative axis of y because this is a force of attraction. We know that is universal law of gravitation. There is always a force of attraction between the two bodies. And we know that is, if we talk about E, is gm upon r square. As the r is increasing, this will be reducing, and as a result at infinity, when it becomes infinite, the E becomes equal to 0. So this will touch this x-axis at infinity. And if we talk about the gravitational potential within this shell till the surface, till it reaches the surface, it is minus gm upon r. So whatsoever the potential at the surface, the same is at all the points within this shell of mass m and radius r. It is same. It is minus gm upon r. Once again, or you can write gm upon r in the negative axis, or you can directly say minus gm upon r. Then till r it is like this, and after that it is increasing, potential is increasing, because the value, as the value of r is increasing, then this will be reducing. We know that is minus 3 is greater than minus 5. So from here it increases, and finally, so eventually when the distance is infinite, then the potential it becomes equal to 0. At other places it is always negative. So is the gravitational potential energy. It is always negative at infinite distance apart. When there is no interaction, when there is no force between the two masses, then the gravitational potential energy of the system is 0. So the same thing is replicated over here in other terms. Let's say we have this shell of mass m and radius capital R, and we are interested in three cases. That is when the point lies within the shell, second is at the surface, and third is when the point of interest lies outside this shell. So let's see what is the gravitational field strength and gravitational potential for all these cases for A, B and C points. When you talk about A point, which is within this shell, then certainly gravitational field intensity that is equal to 0. That is from here to here, that is equal to 0. And if we talk about the potential, potential is minus gm upon r. That whatsoever is the potential at the surface, you can assume the whole mass to be concentrated over here. Then you can find the potential at the surface. It is going to be minus gm upon r. Whatsoever is at the surface, the same is going to be within this shell. So from here to here, it is till r. From here to here, from here to here, it is minus gm upon r. That is whatsoever the potential over here at the surface, the same is going to be within the shell. So that's why it is going to be minus gm upon r. Now we go to the point B. At point B, that is at the surface, the gravitational field strength, the gravitational field intensity, it is gm upon r square. So at the surface, it is gm upon r square. That is for the point B, it is gravitational field intensity is gm upon r square. And what is the potential over here? It is same thing, it is minus gm upon r. That is, we assume the whole mass to be concentrated over here at the center, and we find what is the gravitational potential over here, that is minus gm upon r. Now, if the point, that is, it is C, this point C lies outside this shell. So, to find the gravitational field intensity or gravitational potential, we assume the whole mass to be concentrated over here. So, that's why the gravitational field intensity over here is gm upon, this is R2 we have taken, that is R2 square. This earlier we have taken at R1, and now it is R2. So, gm upon R2 square, that is, it's going to be gravitational field intensity over here, gravitational field strength over here. This is the only magnitude, and if we are bothered about the direction also, obviously the direction is going to be in this direction. That is, gravitational field strength or gravitational field intensity will be in this direction, because this is always a force of attraction only. Now going to Vc, that is gravitational potential at the point C, is, you assume the whole mass to be concentrated over here. The distance from here to here is R2, so it is going to be minus gm upon R2. So what we have done over here, it is nothing but it's only interpretation of these two graphs in this manner. So the points to remember is, that is gravitational field intensity within the shell, that is 0. At the surface it is gm upon r square, and outside the surface you assume the whole mass to be concentrated over here, and you can directly use gm upon r square for the points which are outside the sphere. And if we are interested in finding the gravitational potential, first is find the gravitational potential at the surface, assume the whole mass to be concentrated over here, so it comes out to minus gm upon r. Whatsoever is the surface, the same gravitational potential is going to be for all the points within this shell. So for VA also, that is within the shell, it is same as that on the surface. And if you are considering points which are outside this shell, then you assume the whole mass to be concentrated over here. It is going to be minus gm upon r2, where r2 is the distance from the center of this shell to the point which we are considering.